Okay, so let's keep chugging. We had homework? Well, did I give did somewhere in my notes here? Is this it? Right, the add function? All right. Um, and in Java, right? Okay. So as we are continuing on our voyage to um, really move towards object-orientedness and encapsulation, we are once again rewriting our add fractions thing. And based on the questions I got from just a couple of students, um, they're the right questions, the common mistakes folks make. So let's go through this and talk about it. For those of you who are able to get it, not a whole lot of code, right? But it's important which code it is. Um, all right, so the idea is I even gave you an example here where, we create a couple of fractions, fraction F1, fraction F2, and we go ahead and ask each of those fractions to display themselves. You're gonna hear me referring to objects like that as if they're entities, just like our telephone example. If I hold up a phone, that is a phone entity, an instance of a phone, instance of a smartphone. Or in this case, we have two instances of fractions. One instance is called F1. Well, actually, F1 and F2 are variables, right? They're variables that hold an instance. They hold a pointer to an instance of the fraction class. And each one of those instances is its own version of fraction. One of them holds the fraction, in this case, 1/2. The other one holds the fraction 3/4. Then I'm going to go ahead and ask each one to display themselves. So in this case, I am calling the display method of F1. If we look at the display method in fraction right here, it prints out this dot numerator and this dot denominator. When we are in F1's version of display, who is this? As opposed to when I'm in F2's version of display, who is this? Go ahead.
Um,
Yeah,
I don't
so
know.
the first one display, it's F1, right? So this line right here, if we say F1 dot display, we are coming into F1's version of the display function. So when we say this inside here, that is a synonym for the variable F1. Why don't we say F1 in here? How come I don't write this like that? Go ahead. We don't have access to F1, right? F1's not a thing in here. Secondarily, even if we assume F1 was accessible, let's say that we followed some bad programming practice and we made F1 part of some global variable or something like that. What would be a problem with us writing F1 dot numerator here, even if it was accessible? Yeah, we'd like to be able to create multiple instances of fraction and have each one be able to call their own display method. Not for every single fraction, regardless of which version of it is, uses F1's numerator. So we want to write these things generically. So this is how an object refers to itself from within itself. So when we're looking at F1's display method, inside here, this is the same value as F1 was outside of this. Similarly, if we are inside of F2's version of display, which looks identical, we are looking at every single instance of display's code right here. But if we are looking at the version of display that F2 owns, this is a synonym for F2 as opposed to F1. Okay, so this is how an object refers to itself from within itself. So when we get to add, so right here I said we're going to have a function called add that's going to take a fraction as a parameter, and it's going to return a fraction, which is the sum of this fraction and that fraction, the one that's passed in. All right. So if I go into the fraction class here and I look at the code right here, who is this? If I say, so we'll go ahead and figure out what's the common denominator. So we'll say int common denom is equal to f dot denominator times. Now I'm gonna go ahead and show one of the examples of a problem that people ran into. So I'm about to write a wrong answer here. Common denominator will be f dot denominator. So f dot denominator is the denominator associated with this fraction f that was passed in, right? Okay. Denominator here. Who is that? What variable is that? Go ahead. Well, in this particular case, is it the same thing? Remember, variables resolve to their most local definition, right? That's a hard and fast rule. Whenever I have a variable, it resolves to its most local definition. Now, I have told you that when you can fully describe where your variable can be found, that is, if you are talking about one of the fields owned by this object, say this dot. Even if there isn't a more local version of that variable, or even if there isn't a more local version of that variable, and it will find that one anyways. Specify. If you mean the field, say this dot. So in this particular case, denominator, it's going to boil down to its most local definition. Is there a version of denominator defined in here? Nope. Where's the next scope? Well, we don't get to go inside the other method. So the next scope here is this guy right here. So this guy right here, is there a denominator there? Right here, we have a variable called denominator. So when I just say denominator right here, it will reference this guy right here. Whose version of denominator is this? Is just saying denominator there the same thing as saying this dot denominator? This is this particular instance of fraction, right? The one we're currently working at. So if I say this dot denominator, I'm talking about that guy right there, right? That is the denominator owned by this fraction. How is that different than that? Is it? Variables resolve to their most local definition, do they not? We just said the most local definition of denominator is that guy right there. So this dot denominator and just denominator mean the same thing right there. They are the same. In this particular case, and so the example we just saw is you were uncomfortable with the answer, right? You know, you didn't have confidence in what you're saying. Until you have confidence, don't do stuff like that. Even though in this particular case, it happens to be the right way of doing it. It happens to give you the right answer. I would say it does not follow best practices for doing it. So in this particular case, denominator, just saying denominator, and this dot denominator, these two things in this example mean the identical thing because variables resolve to their most local definition. But when you start doing this, you run into problems until you fully understand this, and you also open yourself up to a kind of a future problem. If denominator here currently does not resolve to a more local variable, but later on you go and put in a local variable that just happens to be called denominator, which, I mean, we're kind of stretching reality here a little bit, but technically that would be legal. Well, then your code is now broken because it's going to resolve to that more local version. As of right this second, this denominator does boil down to the guy up there. But if I were to say denominator right there is equal to -4 for just no good reason whatsoever, just throwing it in there, okay, all of a sudden, without changing this line of code at all, that guy now resolves to a -4 because it resolves to its most local definition. All right. So when you can fully articulate the variable you are talking about, you should. All right. It's good programming practice. Plus, you will have fewer typos. All right. So our common denominator, and that's kind of, so a lot of times what students will try to do when they're writing this one until they wrap their mind around objects, they might write this guy like this. They might say fraction F1, fraction F2. So this add function takes in two fractions and adds them together. When really we don't need two fractions. If I'm a fraction and I'm asked to add myself, add this fraction to some other fraction, I only need you to hand me one fraction because I already know about me. Does that make sense? So we don't need two fractions coming in here. In fact, we don't want two fractions coming in here because I'm adding this fraction to that fraction. In fact, you could even change this and say that my fraction here is called that. Okay, this fraction and that fraction, the other guy. So common denominator would be that dot denominator. Okay, or we could even say the other fraction. Maybe that one's a little bit more descriptive. So our common denominator will be the other fractions denominator times this dot denominator. Make sense? All right. Then we'll say int num1 is equal to this dot numerator times the other fraction dot denominator. Int num2 is equal to the other fraction dot numerator times this dot denominator. All right. So now we want to go ahead and return, well, we want to get our correct answer, right? And we want to build it inside of a new fraction. Okay, because this particular add function, we said, take in another fraction, add ourselves to that fraction, and return a new fraction that is the sum, as opposed to updating us. Okay, we'll look at both of them here, but let's just do it the way it was designed here first. So what I'm going to do is I'm going to go ahead and I'm going to say fraction answer is equal to a new fraction. And when I build a fraction, this guy right here, who is that? I haven't given it stuff here, so I'll just put a couple of question marks in there for right now. When I say that and I replace those question marks with stuff, what am I talking about there? What are the components of an object? If I look inside of a class, what kinds of things am I going to see in that bag? Constructors are one of them. That's what this guy is, right? What else do we see in there? Methods. What's the third thing? Go ahead. Fields. Okay. Every single object you ever run into will be made up of a combination of 0 or more of all those things. Now, if you have 0 of all those things, it's a really, really, really boring object, but technically a legal one. It does work. It's just useless, right? All right. So every object is made up of a collection of 0 or more fields, which are the variables owned by that object. 0 or more constructors, which are the tools, the method-like tools that allow us to build that one of those objects, initialize that object, and then a collection of 0 or more methods that allow that object to do stuff. Okay, and right now I'm speaking about this in generalities because we haven't quite talked about the static keyword yet. We've seen it, but we just kind of pushed it to the side. that changes just a little bit, but in a very important way. Kind of something that I just said. So put a pin in that for right now. All right. Now you mentioned this guy is a constructor, right? How do you know? Okay, so first thing he mentioned here for the online folks, we have a parameter list. When you see a parameter list like that, the opening and closing parentheses, right away you're highly suspicious it's one of two things. What are the two options if you see the parameter list? Constructor or method? Okay, those are the two suspects that we're dealing with here, okay? So you narrowed it down. You basically say, okay, this guy's not a field. Not a field because I see the parentheses. Now, you were pretty confident in saying this is a constructor. Why? What's another reason that that you were suspicious this is a constructor, not a method? Well, this is me using it, right? When I'm using it, you don't necessarily see the return type. When you define a method, that's when you see the return type. All right, so just looking at this line right here doesn't give us enough information that there isn't a return type. So what else? What other, if you're an investigator, right? And you're investigating these suspects and you've got this guy narrowed down to either a constructor or a method, what about this guy starts making you feel like he is definitely a constructor, or at least you're highly suspicious it's a constructor? What other aspects of that line of code make you believe that this guy is a constructor? Go ahead. Okay. He saw the new keyword. Why does that make you think this is a constructor?
You are telling your function, hey, I need a new cloud plan for this.
Okay. So that's what the new keyword is our real estate agent. That's how I refer to it. But that person's job is to go get us memory from the operating system, a certain amount of memory, right? But we've seen this before. We've created arrays with the new keyword. So does the new keyword right off the bat necessarily say this is definitely a constructor? But it kind of goes hand in hand with what you said, in that you said it for the wrong reason, but you were also right in that this guy right here, if we go and find him in the code, we see that there is no return type. At the definition, this is where it's being defined. That's where we see return types. Okay. So now, if it was a method and it didn't return a value, what would we see here? A method that doesn't return a value has what as the return type? Void. It would have that. Well, we don't see that here. We see nothingness. Okay, so when I'm looking at the definition, if I say, okay, well, let's go and find something in my code called that, right? That has some parentheses after that. You start sifting through here, you get up to this guy and says, oh, there's some stuff in my code that looks like that. And I don't see a return type in front of it. Therefore, it's either an error, okay, in this case it's not, or it must be a constructor. Why don't constructors have return types? Both of your answers are highly related, is kind of where I'm going with this. Why don't constructors have return types? Why do we not have to put void in front of it? Or something else. Actually, it wouldn't be void. Why don't we put a return type in front of constructors? It's related to the new keyword. We've already proven why this is important stuff to know, even though it might feel like we're belaboring this point, okay? But you didn't know what numerator or this dot numerator, how those were different, or denominator, or whatever. Okay, these are things that the fundamentals are the most important part. After that, you can with confidence solve problems, right? All right, so why does a constructor not need a return type? Go ahead.
It's not returning.
Well, does it? if I were to build my fraction here, and then I were to say system.out.println F1, what would it print out? Memory address. So why don't constructors need return types? Because they always have the same return type. That is a memory address, right? And if we were working with an older language where we had specific syntax for describing memory addresses, perhaps it would ask us to put in a return type, right? I think I showed you some Objective-C code where technically for a fraction, the return type would be ID, which is a void pointer in Objective-C. So constructors in some older languages where we do have special syntaxes for talking about memory addresses, they might have a return type for constructors. But most of our modern languages will not have that. Most of it is, if you think about a programming language like an iPhone, every single year a new iPhone comes out with some new stupid feature that may or may not be important to you, whatever. But typically each iteration of an iPhone attempts to maybe fix a couple of the things that maybe weren't great on the previous one. And then it breaks two more things. That way they can charge you again next year. That's just the business side, right? But if we're a programmer, we've been writing code for a while, and we're writing object-oriented code, and every single stupid time we write a constructor, we have to put some return type in front of it. We have to type 2, 3, 4, 5 keys, right? To describe the return type of a constructor when we know it is always an address. Why are we wasting our time typing that? That isn't a thing we can optimize, right? If it's always going to be the same thing, don't make the coder type it. All right. So that is why in more modern languages, so this is a true statement in Java, C#, basically all modern object-oriented languages. A constructor does not have a return type. Why? Because its return type is always a memory address. And what that means is we will always see constructors following the new keyword, which is our tool for getting memory addresses. That makes sense? That's the dude who goes and finds us the memory in our computer that's big enough to hold this house that we're building. In this case, the house looks like a fraction. That makes some sense? All right, so there's a connecting point there. And I'm telling you these things, even though when I explain it, it seems simple. You will be doing yourself a benefit to really zero in on this and fully understand it, because this is where errors happen, is in these little stupid details. The bigger things are actually typically easy to solve. Go ahead.
So is that what initial is just like creating
No, not only because, like, for instance, in our fraction here, so for the online people, what he asked is initialization for a fraction just creating memory? If we did not write our own constructor and we just relied on that no argument one that takes no parameters and returns nothing, if we didn't write this, if we didn't write any constructor, Java gives us one under the, we don't ever see it. It just exists. We know it's there. It gives us one like that. In that case, that constructor only gives us memory. It doesn't do anything extra. Okay. But for us, since we're building an object that we want to be a fraction, and we know that at the very least, a fraction needs a numerator and needs a denominator, really three things have to happen here, right? We need memory to put it, and then we need the two pieces of information that differentiate it from other fractions. So initializing a fraction, I broke it. We have the technology. All right. So initializing a fraction. Now, as soon as we write our own constructor like this, Java no longer provides us that empty constructor. An empty constructor's one job in the world is to make that new syntax work. Okay, it says, look, you apparently didn't think you needed to do any sort of a special initialization, so we're going to give you a constructor that takes no inputs, and we'll just make it work with the new keyword so we can get you the memory you need. Okay, but in this case, we decided, hey, building a fraction really requires more than just memory. I also need to know the numerator and denominator to create that fraction. So to answer the question about what is initialization, initialization would be taking in any inputs that this guy needs to build a fraction for you. If you think about him like a contractor you're hiring to build a house, you know, you can, you know, do all contractors work with the same stuff? Or depending on the contractor you hire, you might be able to, if you hire a professional place, you might be able to just cut them a big check and they handle the rest, right? So all that guy needs is a bunch of money. Whereas if you have a buddy coming over to help you, build the house or something like that, he might not need any money, or maybe he needs a little bit of money, but then he needs all the wood and all this other stuff that he's going to need to build that house. You're providing those materials instead of giving him cash so he can go get them himself. So those are two examples of a contractor or constructor who might build your house that take different inputs. So what is it called when we have more than one constructor or more than one method with the same name but a different number and or type of parameters? Go ahead. Polymorphism, fun name. Okay, so if we were writing this for a house builder, we might have two separate constructors. One constructor that just takes in money, and the other one that takes in all the materials you need to build a house, and perhaps some money on top of that, the labor charge, right? But both of those ultimately will get a house built. So they're both considered viable constructors, right? But they both exist at the same time. We just get to choose which one we want. Do we want the one who's maybe a little bit more expensive because we're just cutting them a check and we're going on vacation? Or do we want the one that maybe saves us a little bit of money, but we have to go and source all the lumber and the screws and whatever else they need to build it? Then we're doing a lot more effort, but we have to give them all that stuff in order to build the house. That is to say that it is not uncommon that an object would have more than one constructor. But I would say that it's probably something like 90% of the time when you're writing objects, you probably will only have one constructor that builds the object the way you mean for it to be built. This would be a good example. There's not a whole lot of other ways to build a fraction, right? A fraction needs to have a numerator and denominator. That's the minimum that it needs. So this would be the full initialization process where the new keyword gets us the location, and this is actually initializing the fraction object that lives at that location by setting its numerator and its denominator. All right. So we know that this guy is, well, let's see, I'll go down to where I was. This is the same example here, but we'll go down where I have my question marks here. We know this guy is either a constructor or a method because of the parentheses. We're suspicious that it's a constructor because of a couple of things. First of all, we see the new keyword, and if that dude's hanging around, it's not a method. It's either a constructor or a syntax error. All right? Because methods never are called right after the new keyword. It doesn't make sense. Methods do something and either return no value or they return whatever value they're supposed to return, int or whatever. So they either return void or they return something. Okay. But in none of those cases do we need a helper to give us our return value. The new keyword gets us memory addresses, so he's going to be associated with constructors because they always boil down to a memory address, the location where that object was built. All right. So we're highly, highly, highly suspicious that this guy must be a constructor because we see this dude, the new keyword. And what seals the deal for us? If we see that, what's the other thing that drives the point home that this must be a constructor? In this language and C#, most modern languages. If you know anything about Objective-C, pretend like you don't know that for the purpose of this question. Go ahead. Okay, so He said, not the answer I was looking for, but he said, well, if you look over here at the left side, because whatever I'm catching here, whatever this boils down to, which we know will be a memory address, I'm catching it inside of a variable called answer that happens to be of type fraction. So in that particular case, that's correct. That because the way I'm using it, well, that guy better be a constructor because that's I'm putting it inside of a variable that I intend to use as if I have a built fraction somewhere. All right, so that's true. What if we just focus on this side? What seals the deal other than that new keyword and other than the opening and closing parentheses that says this guy is a constructor? Class name, good. Yeah. Class name in this case is fraction. Notice the constructor must be identically named the same as the class name. Capitalization at all. Capitalization matters. All right. So that pretty much seals the deal for us where we can say, okay, this guy is either a method or a constructor. All right. It's looking a lot like a constructor because I see the new keyword there. And okay, we're across the finish line there. I see the name of this method like thing is the same name as this class. That dude's a constructor. Make sense? All right. So important stuff because keep in mind, you're not always going to be writing the code. In fact, this homework was as much about being able to read code as writing it because I gave you the way I want your method to be called. On this assignment, I gave you this part. So if you didn't go and write, and I even gave you the header for the function, right? I gave you this part. So if you couldn't get it to work this way, because of what I saw some of you do, you went and modified this here to take in more than one thing to get you the two fractions you wanted to add together because you weren't comfortable using this keyword yet. Make some sense? All right. So I gave you kind of where the fence posts were, and you were going to run into syntax errors until you wrapped your mind around kind of the interesting sightseeing pieces of this. All right. So in this case, I have my common denominator, which is the other fraction's denominator times this fraction's denominator, where this fraction is whoever's version of add was called. Notice out here in main, I called F1's add function, but I also called F2's add function. We expect both of these to output the same thing, right? Because it doesn't matter if I'm adding F1 to F2 or if I'm adding F2 to F1. Adding two fractions together will give you the same result, regardless of whose version of the add method I call. The difference is that if I call F1's add method, the other fraction will be F2. If I'm calling F2's add method, the other fraction will be F1. But inside of both of those, F1 or F2 will be referenced as this. The fraction whose add method is being called, because this is how an object refers to itself inside of itself, because we don't have that variable that lives externally that we use to call this function. Make some sense? All right. So we have our common denominator. We have our first numerator by cross multiplying between this numerator and the other fraction's denominator. We have our other numerator, which is the other fraction's numerator times this fraction's denominator. Then we're going to go ahead and build our answer, being a new fraction whose numerator will be num1 plus num2, and whose denominator will be common denominator. Ultimately, my add function is supposed to return a fraction. I have a fraction right here called answer, so I'll go ahead and return answer. So out here in main, we define a couple of fractions. We go ahead and display our two fractions, just kind of showing off how each fraction knows how to call their own display method, right? Then we'll go ahead and add a couple of fractions. We'll add those fractions to each other from both angles. We'll ask F1 to add F2 to himself. And then on a separate line, we'll ask F2 to add F1 to himself, getting answer 1 and answer 2, which should be the same answer, since the nature of adding fractions doesn't matter who called, which order they were called in, you're still adding the same fractions. Then we'll go ahead and ask answer 1 to display itself. Answer 1 is the result of calling add from F1, passing it F2. And the result there is this guy right here, us returning the answer. Answer 2 is the result of F2 calling his add function, passing F1 in as the other fraction. That will be this guy right here. Go ahead.
How will you pass out answer when the return is?
I mean, the return's fraction, right?
Yeah.
Here's answer. What's answer? Well, answers, so go down the path. Answer is a variable. And this variable holds a memory address. And that memory address points to a place in memory. And what lives at that place in memory? A fraction. Right? I've advertised I'm going to return a fraction. Answer effectively is a fraction. Okay, I'm just kind of popping the hood and telling you what's actually under there. So whenever we see something like this, we start off by saying this animal is a variable. Then we might say, what kind of value lives there? Well, it's going to be a memory address, because I see the new keyword there. All right. Well, what is that memory address in reference to? Well, I'm building a fraction here. So at the end of the day, if I use this variable, I'm really talking about a fraction. I got a fraction object somewhere down that pointer line, but Java handles all that for me. So answer, like you said, is ultimately a fraction. And that's the guy I'm returning. I've advertised I'm going to return a fraction, and I have returned a fraction.
Why does it not die?
Why is it not? What do you want? What could I say there to, you said, why is it not die?
Why does it not die within that?
Well, it does. You mean right here? Because of the keyword return? Return makes a function immediately end. Is there anything following that in here? No, it's over. So I'm not held up on this line of code. Add does end. When answer gets returned, I capture that value here, and then I move on to the next line of code. This version of add does all of its magic, ultimately returns a fraction, and then this guy ends. So now I'm here. I ask answer 1 to display itself. Answer 1 is the result of F1 calling his add method on F2. Answer 2 is the result of calling F2's add method on F1. We expect both of these to display the same result because we are asking the object, the fraction object called answer 1. We're saying you display yourself. Then we're saying answer 2 is another fraction standing over there looking all mischievous or whatever. We're saying you display yourself because we know the nature of adding fractions means these guys should both be the same thing. We should see the same result for both of these guys. So here's this is F1 displayed. This is F2 displayed. Remember, all programs begin and end with main. So we're just walking through main here, watching main play quarterback, right? Then we add them together. So there's no visual output from these two lines. Logic is happening behind the scenes. But then we're asking answer 1 to display itself, which gives me that. And then we're asking answer 2 to display itself, which gives me that. Make some sense? All right. Does that solve the homework? Did I ask you to do anything else? Did I ask you to reduce or anything? Okay. All right. So I'll go ahead and save that. and share this code on Slack. Just as a reminder here, I put this up on Slack earlier today, but there's and I just found out about it. The advisors emailed it to me, but apparently there's a career night at Concordia tomorrow, November 13th, in the School of Pharmacy atrium. So that's over there, pharmacy school, starting at 4:30. So there's going to be various job people there. There's probably going to be food somewhere. Um, Looks like West Bend Mutual. So these have hired some of our CS students, West Bend Mutual. Um, Anybody know anybody in here who works at West Bend Mutual or online before I badmouth them? We haven't had good experience with West Bend Mutual with at least with our computer science interns. Perhaps it was a bad manager or something like that, but truth in advertising. I can't necessarily remember if we've had any students work at Baird. We've had many, many, many work at Northwestern Mutual. So that's typically considered to be a pretty good employer. I know insurance companies seem boring, and Northwestern Mutual is going to be more boring than Acuity. Acuity has like rock climbing walls and stuff like that. I think Northwestern Mutual probably has like a day per week you don't have to wear a tie, something like that. But this would be worth, especially if you live on campus, worth popping into and just seeing if there's anything interesting there, just to get a taste for what's out there. Even though most of you are freshmen, that doesn't mean you can't start looking at internships and things like that. So take advantage of that. It's there under the general channel on Slack if you want to go and look at that. All right, and there's the solution. So we'll call this fraction add solution. Okay. So now that go ahead.
You know how you said that, like maybe for companies don't want to reuse the same assets or like the memory over and over again?
Mhm.
Do you think EA does that with their, yearly sports games? Because I swear it's like they have the same game, and then they add stuff and then they remove stuff. So you think they're
And then charge you again?
yeah, and it's like microtransactions. So do you think the software developers just like reuse the same stuff? Or
Well, I think a lot of the logic could be the same. So like so the kind of the question was for the online folks, when you look at actual software being released by places like he's talking about EA Sports with their yearly sports games like Madden and that kind of stuff. Um, Sometimes from year to year, the game will feel almost identical, just with, if we were talking about NBA 2K or whatever, just the players who were traded end up on the other team, so they just swap out jerseys or whatever, but maybe the controls and stuff feel the same. So it's possible that would be kind of an intermediate kind of upgrade. Typically, what you would see in that example is not a substantial amount of the logic would change. Sometimes what they'll do is when you get an update to a video game or something like that, you might notice that the core game has not really updated, but they add new kind of bolt-on features. So, I think I mentioned like I play World of Warcraft, and so World of Warcraft has been around longer than any of you have been around. But the game today has a lot of the same pieces as that game had 25, 30 years ago. But there's been so many bolt-ons, a lot of them gaming would call them quality of life stuff, right? In the early days of World of Warcraft, I'd be standing in the middle of one of the main cities yelling that I was looking for a group for Blackrock Spire or something like that. Like DPS looking for group Blackrock Spire. Well, now there's group finders where you just click a button. You never even have to talk to another human being. You even I used to have to travel to the dungeons. You like some group says, okay, you're in. Meet us at Blackrock Spire. We're about to walk in now. You got a 15-minute commute to get there. Now you don't even have to move your guy. You just log in, you click group finder, and poof, you teleport right in there. You're good to go. But the core game hasn't necessarily changed the time. They've added spells, they've added things like that. But
their logic, some of that code, I'm sure plenty of code that was written 30 years ago is still there. So you really have to look at the nature of the game. A lot of times they have added new features, so you do have new logic. And then you might have old bug fixes, but a lot of times those come out in patches. So whenever a game has a patch, typically that is updating existing logic. Typically, major revisions of patches might have new features, but minor revisions of patches, like if you're currently running version of the game 3.2 and 3.3 comes out, that's probably a minor revision when it's after the decimal point, fixing some bugs, things like that. But when 4.0 comes out, that's probably a beefier update that maybe has a couple of these bolt-on things. And typically those are free. But then every year, every couple of years, when they charge, they want another $80 from you. They release the, whatever, Madden 2025 or whatever it is, give us your money. And then you're at the mercy of maybe it's updated graphics, updated textures, because the system can handle more, whatever it is.
So how would downloadable content work then? Would that just be, once you pay the money, you get that like more code into the game?
Oh, well, so he's asking about downloadable content, DLCs for games. So so most DLCs in most games, since they try to avoid the phrase pay to win, right? So most of it is cosmetic. So a lot of times that's just graphic artists pumping stuff out, right? Throwing it up there, it says, hey, here's a new piece of armor or whatever your guy can wear. It makes no difference in gameplay, but your dude looks awesome. Something like that. And that's important to some people, not important to others. So like I've never bought anything cosmetic. I don't care. And whenever I'm creating a character in a game, I always just hit the randomize button. Just make my deal. Let's get in there and start shooting stuff. Okay, but some people really, really, really care about the look of it. So I mean, you can see some of these games, like even World of Warcraft. I just got back into it for the newest expansion. So I created a new character just to kind of get caught up. I hadn't played in like 5 years, but the number of options for customizing your person's look seemed obscene. I mean, I was like, the length of eyelashes was part of it. But in any case, things are important to different people. So the people creating that content might be graphic artists. You would have some programmers involved there, but imagine if you're changing, hitting the buttons to change the hairstyle, where there's maybe 15 different hairstyles. That's an if statement, or when they click this button, shift to next hairstyle in array. Go from bucket 0 to bucket 1 to bucket 2 to bucket 3. Once you get to the last bucket, wrap back around to bucket 0, right? And that's all logic that we understand in here. Okay, so a lot of times the coding behind that is not difficult coding. Yeah, you're just dealing with talented artists that make things look good or whatever. But everything's a money grab. Right? I can't blame them. When you really consider, like when a game comes out and it's $50 or $60 now anymore, they have like 3 versions of the game. They have like the normal version and the ultimate version and the super epic, life-changing dinosaur version, whatever it is. It's the same game, but it comes with extra cosmetic stuff. Maybe it's something you can't buy. Okay. But the idea is that, okay, well, it might seem like 60, 70, $80 for a game feels expensive, but consider that you're spending 200-300 hours or longer playing some of these games, right? Okay. And think about all the money. You guys want to get a degree in computer science and go out, and I assume all of you want to make more money than minimum wage, right? So you kind of would like to maybe start at $70,000-$80,000 a year, get up to 6 figures sooner rather than later. Well, you got these giant AAA studios, Bethesda, Blizzard, Activision, whatever. Well, you got more than like one dude sitting in his basement writing that software, right? You got a team of 300 developers all making 6 figures. Somebody's got to pay them. So when you consider that $80 is getting you 300 hours of entertainment, it's actually a pretty good deal, right? We don't see that as consumers because we're so price driven. So remember that next time you're buying software, and you know, instead of stealing it or something like that. I mean, look, I'm not the ethics guru, but understand that it's actually pretty cheap when you consider that what you're getting for it. So whatever. All right, other questions? All right. So now we could certainly add some more features to this. We can maybe build into a fraction. We can say, hey, shouldn't fractions be able to reduce themselves? For instance, I should be able to point at a fraction and say, you reduce yourself. So let's go and add into the fraction class. I'm going to say it's called void reduce. All right, so I'm telling you that's what the method header should be. This guy should reduce this fraction by updating this fraction's numerator and denominator to be in reduced form. Why is the return type void, first of all? Actually, before I ask that one, that would be question 2. Why does this guy not need any parentheses or parameters rather? I need the parentheses because that is a method, right? We know it's a method because of the opening and closing parentheses. We know it's not a constructor because it has a return type and it's not named the same as the class. We're in a class called fraction, not in a class called reduce. All right. But why doesn't this reduce function, which I would call like this, I would call answer 1's reduce function that way. And then I plan on being able to ask answer 1 to display himself again, potentially getting a different output than I got right here, unless the fraction was already fully reduced. So why don't I need any inputs here? Go ahead. Huh? This. Who is reducing themselves? This is reducing themselves. When I call it from out here, when I say answer 1 dot reduce, I don't need to give reduce any input because reduce already knows about answer 1. Inside of reduce there, the keyword this is answer 1. We already have access to the numerator and denominator that we're reducing. All right. Why is the return type void? Shouldn't I be returning a new fraction? I could, right? Go ahead. Nope. What is reduce actually going to do? I wrote it right here, right? Reduce is going to have this particular fraction make some updates to himself. Okay. He's not generating a new fraction and then throwing that out there. We could say that, hey, whenever we reduce a fraction, we don't actually want to change the original. We just want to produce a new fraction that is in his reduced form, right? We could say that, but that's not what we're trying to do here. What we're trying to do here is we're pointing at 10/8 and say, look, you need to cut down on the nachos. You're a little, you need to reduce a little bit. Okay. So we're pointing at him and say, reduce yourself. And we expect him to internally become 5/4, right? Which means that he will be updating his own numerator and his own denominator to their reduced form. So after that function is called right here, if I go to display answer 1 again, I expect it to now display 5/4 because I have internally modified the state of that instance of fraction. Okay. Make some sense? All right. So to write this, if we want to write reduce, you know what? Actually, just for, I'm going to leave this. This will be our homework assignment. So put a pin in this right now, but let me talk about some other stuff that's going to be important here that I'll also make part of the homework so the homework becomes something that upsets you. All right, so let's start, so we'll say, write this function for homework. Now, I'll give you the final version of the code to go and do that. Okay, so we're going to introduce something new to start filling in some of these gaps. So we have something called object security, could be called some other things. And we have the idea of public, private, protected. Now, up to this point, we've seen that word public before, but we've kind of just shoved it to the side and say, you do you mean what you mean, whatever. All right. But so where we've seen that so far is we've seen that in the class name or in the class definition for the class that has main in it. That guy has to be public. He has to be public because the virtual machine must be able to access him. And we've also seen it with main. Also needs to be public so that the virtual machine is able to call main. All right. But those guys actually have underlying meanings. It's not just, oh, just leave it alone. Don't worry about it. That's what we've set up to this point. So these security measures can be put in front of any member of a class. What are the members of a class again? What are the three things that can happen inside of classes? Fields, constructors, methods. So a field can have public, private, protected in front of it. A constructor can have public, private, protected in front of it. That's a little bit of a harder, a more unique thing to have a private constructor, but it is possible. We'll talk about that at some point. It could also have protected in front of it, any of those guys. All right. So what if nothing is in front of a member of a class? The default behavior is package level security, or anything in the package. We're going to say for right now, what this means for us is same directory has access. If you go to C#, instead of the word package, it's the word namespace. And we've seen that in C++, just organizational units. You can basically just think of it as like, look, if you don't do anything special, if you don't put one of these words in front of it, hopefully you have a good reason. Maybe it's because this is throwaway code, you're just writing something for 5 minutes. But typically you'd want to have one of these in front of it. But if you choose not to put one of these in front of it, you're basically saying anything that's inside this current directory where this file lives has access. All right. So public means everyone has access to this. Private means only this particular class has access to this. That is, it's only accessible from within the class. And we'll see examples of this. This is going to be super common, private. Protected means only this particular class and children of this class. This is inheritance, which we haven't talked about yet. Inheritance. Have access to it. All right. So we're going to have a rule of thumb here.
make everything private initially, then loosen the security as necessary. Now, once you do this enough times, you'll kind of know that you're probably not going to make constructors private. It's just not a common thing. Constructors will probably either be nothing, which means they're package level, or they'd be public. But I'm still get your training wheels off, get used to making everything private, and then when it doesn't work, understand why it's not working and loosen it. So go from private to maybe protected to maybe public, just depending on who needs to have access. And this will become more and more clear as we keep working with this stuff. All right, so let me show you an example of this. All right, so here I'm creating a fraction called f1. It's going to be the fraction 1/2. The very next line, I'm attempting to print out f1's numerator. What do we imagine f1's numerator is? 1? All right, so if I go and run this, there's my 1 right there. Now, if I go inside fraction, notice we didn't put anything in front of numerator here. If I go ahead and make it private, which is what I'm suggesting, you make everything private initially and then loosen the reins as you need to. And really, I'm mostly talking about the fields when I say that. But frankly, it's fields and methods are probably the ones that this makes the most sense for. Make it private and then decide who actually needs to access this. So just by putting private in front of there, doing nothing else, what does private mean? Private says only this particular class has access to it. That is, I can only access this variable called numerator from within the fraction class. Let me ask you this. Right here, I am trying to access f1.numerator. What class am I in right here? What do we see on line 4 there? This class is called driver, right? Is that a misspelling of the word fraction? Pretty bad misspelling, right? Okay, this is not the class fraction, right? This is the class driver. And by this definition, by making it private, it's only accessible inside that class called fraction in this case. Since I am not inside the class called fraction, instead I'm in a class called driver, Java should have some serious issues with this. Because I'm trying to access what would be called a private member of the fraction class from outside of the fraction class. So let's see it screen. Numerator has private access in fraction. I can't do this. Okay. Now, a beginning programmer, their approach might be, oh, well, I don't really know what's wrong, but I've discovered if I just delete this, all of a sudden it works. That must be correct. Not knowing why. That goes back to the idea of don't just change stuff till it works. Because the correct solution isn't what you're looking for. You're looking for the knowledge of how you got to that correct solution. All right. It's going to be pretty rare / lazy if you don't put anything in front of these fields. But if you're just writing a real quick program just to solve some stupid thing and it's going to be deleted 5 minutes later after you're doing it, don't spend extra time on things like that. But at that point, when you're at the point in programming where you might just do that because it's quicker than like solving it with a calculator or something like that, you will get to that point where it's faster to just write it in code. Promise, you'll get to that point. Once you're at that point, you are allowed to choose to be lazy if it's for a good reason.
right? Nobody else is going to be dealing with this. But if you're writing code that somebody else might be using, like one of our fractions here, we want to make sure that we've put the right protections in place so that they don't either accidentally or maliciously misuse it. We don't want them, because as it is right now, where it's showing me that one, I can now print out my fractions. There's my 1/2, my 3/4. Here's me adding them together. There's my 10/8. Here's me displaying answer 1 again because I haven't actually changed anything. We expect this guy to ultimately be different. I just haven't actually reduced anything. I've called a function that says reduce, but reduce currently is waiting for you to do your homework. That's what that guy does. It's a very boring function right now. It's just a pass through. All right. But after I reduce that fraction, regardless of whether it's doing anything or not, I could say something like answer 1 dot numerator is equal to -7. Just because. Now all of a sudden, my reduced fraction is -7/8. I have externally modified something that I did not anticipate or want my users of my fraction class to be able to do. I want this thing to be a self-contained pod. And if the numerator and denominator will change after it's initially built, that change would be handled from an internal process inside the fraction. I shouldn't be able to come along and just short circuit the whole thing and say, look, you got a new numerator because I said so. As we have it written right now, we can do that. If I throw private back in front of this guy, now I can't do it at all. It's going to yell at me twice. First time when I try to directly update F1's numerator here, well, when I not update it, when I try to access F1's numerator. So understand that when I make it private, here, I'm not trying to change it. I'm just trying to get at that value directly. Well, it's not going to let me do this because I'm outside the fraction class. So it doesn't give me even read-only access to it. This one, I'm trying to actually modify it. Certainly is not going to give me write access to it. So this guy's going to, it might only scream once because it hits the first error. Yeah, there we got this. We got both of them screaming. All right, so that guy's off limits because it's private. So I'm telling you that this is the more correct way to write it. Now, it makes perfect sense that we might not want to be able to allow somebody to externally modify our fields. But what about reading the field? Might it be reasonable for us to say, I'm interested in just specifically what F1's numerator is. I don't want to be allowed to change it, but maybe it's convenient that I have access external to the fraction class, the numerator, for read-only purposes. So knowing what you know now, only what you know now, how might this line right here is not going to work. We're going to take that one out where we're modifying the numerator. That's probably not going to make sense. No, I don't see a world here where we're building a fraction where we have the intent of letting people destroy our fractions from the outside. Okay, but maybe we say, look, this isn't Fort Knox here. If you want to have direct access to the numerator and denominator for read-only purposes, that's not the worst thing in the world, right? So knowing only what you know right now, how might we give the driver class read-only access to that private variable? I can't make it public, right? Making it public is not going to, it will make it readable, but it'll also make it writable. I want to make it read only. I can get the value, but I can't change the value. So knowing only what you know right now, and I'll tell you, this is something we did not learn in class today. It's something you've already previously learned. How might we expose that numerator value to driver in a read-only way? Any suggestions? It has nothing to do with that line of code I have highlighted right now. It's something we've learned before this class. Before
Do we
this.
copy it into a new variable?
Well, then that new variable would be able to be changed, but that's actually not a horrible idea. She's maybe suggesting, okay, well, we have, int num maybe, and we leave all the permission stuff off of that. And then when the numerator changes, we say this dot num is equal to numerator. Okay, so now we do have external access to num because that guy is not private, right? He's package level, so we have external access to him, but if we change him, it does not change the original. Technically, that would work, okay? So let's go with how else. Good. Yeah, so we have these things called getters and setters. So I'll just show you the example first, because this is really more of a vocabulary word than anything meaningful. It's not special syntax. But we might say, hey, I'm going to go ahead, and because I want to give somebody else read-only access to this numerator, which is an int, I'm going to go ahead and say, okay, I want to write a function here that returns an int. Typical naming conventions for getters is to call it get, and then whatever the variable name is, like that. But it doesn't have to be called that, right? This is just naming your functions in a meaningful way. I want this guy to be able to get me the value of the numerator. And then this guy will just return this dot numerator. So now out here, I can't say f1 dot numerator because that guy's still private. Numerator is still a private variable, but I can say f1 get your numerator. And now I have access to it. But this is read-only access to that guy. I can't say something like this, f1 dot get numerator equals -7. That's not how functions work, okay? I could have a setter. I could say f1 dot set numerator and pass it a value and let that change it. All right, but that's probably not going to be what we want here. We want to give read-only access, which is what we just did. All right, so I'll put the homework assignment up. I'm going to give myself a little getters and setters. Start here. All right, but so your homework for next class, and I'll give you the right starting point, is to write this reduce function right here that updates a fraction internally so that when after I call reduce on it and I print it again, it's now in reduced form. All right. So I'll make sure I remove a couple of the other things just so it's focused on that rather than this getter. We'll start talking about getters in more detail next class. All right. Questions, comments, concerns, bribes? Go ahead.
I guess, is there a quick way to explain the difference between public and having no option or like just having a blank?
Yeah, so he asked, is there a quick way of describing the difference between public and package, having nothing in front of it? Public means literally anything on the operating system that can somehow get access to this folder would have access to it. Where package says only things that live inside the same folder as this guy would have access to it. To your point, it's a little bit of a tough thing to show an example of. So really package is lazy. Yeah, putting nothing in front of it, basically having having this package feature is more of a catch-all to keep you from having screw-ups. C++ actually has a security feature for that called friend. In C++, instead of it being package level, it's a friend of the class. Okay, kind of a guy I know. He's in the same directory. All right, I will see everybody on Thursday. Remember, we do have the computer science retro gaming flippy thingy tomorrow. I'm going to show up to that. And then the job fair thing, whenever that was. So check out those things. One second. Let me just make sure there's no questions on here and then stop the recording. Okay.